Welcome back, Contemporary Math. We are in chapter 3A, and so we are starting to talk about percentages in here. So this chapter is titled Uses and Abuses of Percentages. So we're going to talk about a few ways to do percentages correctly, and then we're going to talk about a few common mistakes that people make when they are working with percentages. And so there are three ways of using percentages. And so the first thing that they talk about is using percentages as a fraction. So if we use a percentage as a fraction, p%, the word percent, there's the word per, and then there's the word cent. Per literally means divide. So we have miles per hour. That's literally the units of what? Miles divided by hours. So when you see that word per, I think we talked about this previously, that means divide. The cent means 100. And so we're talking about cents in a dollar. There's 100 cents in a dollar. The centennial is 100-year anniversary. Bicentennial would be 200 year. So we divide by 100 is literally what percentage means. So p% would be whatever number's there divided by 100 is what we are talking about. So if we look at the first example, it says an opinion poll finds that 75% of 2048 students surveyed said that their professor was odd. So how many students believe that their professor is odd? So if we want to write 75%, that literally means 75 out of 100. And so what we're doing is we're comparing this, the number of students that think their professor is odd, to the total number of students. And we're comparing that to 75%. So we're comparing two fractions is what we're doing. And so if we want to think about this, we're comparing this to another fraction. And so I'm thinking about percent. Sometimes they say it's part over whole. So I guess I could also define it in that way. Sometimes people define it percent is equal to some part over some whole. And so we have our percent, 75%. It is some part over some whole. And so we see this number of 2048 students. And we're thinking, is that the part or is that the whole? That is the whole population of the students. And so what we're asking is, what is this thing right here? And so I could put a question mark. I guess I could put a variable x up in here. And there's a few ways to do this, but I believe the simplest way is probably just to do the thing known as cross multiplication. So if you have a fraction equals a fraction, we can look across here, we can look across here. And so the two equations I'm getting is 100 times x, or the two expressions, I mean, and the equation that I'm getting is 100 times x is equal to 75 times 2048. Let's look at the 75 times 2048. And we have to divide 36. And I'm talking about students here. So this is certainly one way you can do it. Another way, if you see 75% of 2048, what that literally means is that we are multiplying this. So if this is 0.75 times 2048, you should get the same thing. So I did it without saying it, but what you have to do is you have to translate this percentage to a decimal. So we are converting the percentage to a decimal, and we are multiplying by 2048. And probably definitely using a calculator at this point in the game, but this is 1536. You should get the same number of students. And it should look very similar. Well, maybe not. But this is essentially the same problem, just written a little differently. if we wrote this as a decimal, let's see. We wrote this as a decimal, 0.75 equals x over 2048. So we wrote that as a decimal and did that over 1, and you did your cross multiplication, you would get the same problem. Just writing it a little differently. Okay. So there are two sorts of changes they talk about. I'm going to skip over them and then probably come back to them. But if I'm going through and I want to talk about, let's go back. I already messed up on this. So there's a little typo. We should probably say the 2017 senior class is 250 students. And then the 2018 senior class is 375. And there's two sorts of things that they're going to talk about. And I skipped over the formulas on purpose. I'm going to jump back and talk about them after we do this problem. I think if we just lay out a problem, it would be easier to sort of talk about. So if I want to talk about a change in these two classes, we went from 250 to 375. So the first thing they talk about is this thing called absolute change. And this is a thing that is pretty straightforward. It is just the thing that you would think about probably if I asked you for the difference of these two things, right? What is the change? The first thing you'd think about. What is the difference of these two things? It should be, what's that, 125? The other thing that they talk about is relative change. So we want to know what this thing is relative. Relative to what? It's going to be relative to the original. So I don't remember, how did they do it? They say absolute value or absolute change is the new value minus the reference value. So that was the first thing that we found, that was absolute change. The next thing that we're going to do is we're going to take that absolute change, we're going to divide it by the original number, and then multiply it by 100 to make it a percentage. And so new minus reference should look like 375 minus 250. That's the difference that we had. We're going to divide this by the original reference value. So our reference value here is the 250. That's what we're starting with. This is going to give us some fraction. So the last thing we have to do is we have to convert it to a percentage, is what that multiply by 100% is telling me. So what is this going to give you? This is going to give you 125. We already figured out the numerator previously. That's the difference. We want to know what this difference is relative to the original thing, which is 250, and then convert it to percentage. So 125 over 250 should give me 0.50. And if I want to know what 0.50, so 0.50 decimal means 50%. And so what we would say is that this class is 50% more than the previous class. They are 125 people more. Or we could say they are 50% more than. Okay. Example 3. All right, now we're looking at number 3. The average rate of tuition for a 4-year institution in 1977 was $25.77. The average tuition in 2007 was $18,445. Find the absolute and relative change. So again, the absolute change is hopefully straightforward. It is the first thing that you should probably think about, absolute change, when you hear about something increasing. It is, let's take the difference between 18,445, and we're going to subtract that by that other number there, 2577. If we do that, we should get 158.68. Okay. So now we want to talk about relative change. Swapping out an aunt for an uncle. No, that's not what it is. Two nephews for a cousin. Is that how that works? Okay, so relative change. We want to do new minus old over old, basically, is one way to think about it. We're doing 18,445 minus 2577. We're dividing that by the old thing that we started with, which is the 2577. So this is going to tell us the percent increase. And since it's giving us a decimal here, we want to convert it to a percentage in the end. You've already done some work. You know that this top number is 158.68 over 2577. And we're multiplying by 100%. Okay. So let me double check this, make sure I did it right in my notes. 158.68 divided by 2577 should give us something like 6.1575. And then I still need to convert this to a percentage. So you might notice that this is a larger number than this number. So we are getting something that is going to be above 100%. This thing is increasing by more than 2,000 to 25,000, right? So we're going to get something fairly large. So we move this 2 decimal places. This is increasing 615.75%. So it's 615.75% more. Okay. So now we're looking along. We got example 4 we're looking at here. We want to find absolute change. We want to find relative change. So I am hoping you're getting the hang of this thing by now. You should try this thing for yourself before I do it. Pause the video. Don't let me go ahead of you. And get this thing down. I want to do the absolute change. I want to go new minus old. So a phone that is normally cost $10.21 is on sale for $7.28. Find the absolute and relative change. So this one is a little bit different from the previous two. And it's a little bit different because the price is going down. So now if we do 728 minus 1021, we still want to do new minus old. This is not going to give us a positive number, something you might realize. So 1021 minus that should give me minus 293. So our change can be negative. If it goes down, it's going to be negative. If it goes up, it's going to be positive. So our absolute change can be negative. And if that's the case, then what's going to happen to my relative change? So I know I'm writing this thing over and over again, 728 minus 1021, and I'm writing it over because it might sort of help you. But if you can notice sort of shortcuts, that maybe this is the same thing you figured out previously, then you probably skip a little step, right? That's not a big step. But this is why I want to write it out. What number am I putting on bottom here? So don't let this mess you up. I still have to do the old number on the bottom. So this is minus 293 over the 1021. And then I have to convert that to a percentage. So this is giving me something like minus 0.28697. And then I still got to convert that to a percentage. I'm running out of room there. But we convert this to a percentage by moving it 2 decimal places to the right. So this is a negative what? 28.697%. So 2 to 3 decimal places is probably pretty good. So maybe to recap, our absolute change can be negative, and if our absolute change is going to be negative, guess what? Our relative change should also be negative. Okay, so we used percentages. So they're going about percentages as 3 different ways, using percentages as fractions, using percentages to describe change, and then the last thing that they're going to use percentages as, or kind of group or categorize them as, I guess, is to use percentages for comparisons. So this, I'm going to say, is no different than that sort of previous thing that we did, except there's not like a sort of time factor. So in all the previous problems, where is it? There's it is. Ooh, dropping my calculator. So you might notice this looks like new minus reference, and this thing looks like compared minus reference. So instead of comparing something like from 2017 to 2018, something that's new minus something old, we're just going to have two things that we compare. So they could come out at the same time, they could not. We're just comparing two items the same way that we compared two things previously. There's just not that time factor that's in there anymore. But it is the same comparison. If we have an absolute difference, we're talking about, and I can't say new anymore, new minus old, but it is a compared minus the reference. And if I do the relative difference, it's the compared minus the reference over the reference times 100. So maybe an example to get at it. These examples are going to date themselves pretty quick, I think. But here we go. This was the prices at the time when I looked them up, I think. You are interested in buying a game console. You found an Xbox One X for $500, and you found a PS4 for $300. We want to know the relative difference. So the absolute difference would either be positive 200 or negative 200, depending which one you picked for your reference value. So we want to look at this. And I guess I'm going to go first for 500 minus 300. If I do 500 minus 300, my reference value now, I have picked my reference value to be this thing, which is 300. And I still have to multiply this by 100%. So this is giving me 200 over 300, which is basically 2/3. So I believe this is going to give me something like, I'm going to do this a little quick, but this should give me something like 66.67 or 66.7%, somewhere around there. Okay. So I want to think about these two things. And the $300 was the PlayStation. So this is saying that the Xbox is what, 66.7% more than the PlayStation. Now I did it this way, and I kind of said it really quick right before I started working this problem, but I can kind of think about it the other way. What if I want to switch these so that my Xbox is the reference? So I can absolutely do it the other way. So you have to specify which one you want your reference value to sort of be. Somehow, some way, you have to sort of ask which direction, or I could ask you to maybe solve it both directions. but this is going to give me a little bit of different number. This is a minus 200 on top. And on bottom now I have 500 as a new reference number. So previously I had 300, now it goes to 500. I'm doing a different reference. This is giving me like minus 0.4. This is, I'm going to go real quick, but this is minus 40% is what this should calculate to. Minus 2/5 is minus 4/10, which is a minus 0.4, which multiplied by 100. So what's happening is the PlayStation is 40% less. Ooh, let me do my percent sign. That's what I meant to do. Okay. And this is what, $300? So maybe if we do this. So maybe there is one sort of thing maybe to take away from this problem. You could say 40% less than, right? Or 66% more than. So what is that? Like, you might maybe expecting these things to be the same, right? And why are they not the same? So maybe one of the lessons to take away from that is that this 66.7 in percentages, they are a ratio or a fraction. They don't actually tell us like any sort of thing about the raw number. They just tell us about a sort of relationship that's happening there. So this is relative to something. And one of the ways that we're going to see that you can manipulate people with the abuses and percentages is that like you have to know the base number that this is based off of. So this 66.7% is based off of 300. This 40% is based off the 500. So they are talking about the same number, which is between the two. They're both talking about $200 is what they're talking about. But this one is based off of 300 and this one is based off of 500. So the raw amount that they're talking about is still the same. This is the part to the whole. This is the part to the whole, right? This part to this whole will give you this. This part to this whole will give you this. So you got to know the whole in order to know the part. So just giving someone a percentage is a real good way to sort of really mislead them really quick. Without knowing what the whole is, right? We want to talk about versus more than. So this is the vocabulary. So far I have been talking about the more than. So if I talk about a class of 10 quadruples to be a class of 40. So if I want the more than, that is the relative difference. If I take 40 minus 10, divide that by 10, convert it to a decimal, what I'm getting is that this is going to be 30 over 10. So 3, and then I have to convert that to percentage. So this should give me 300%. And so one of the things I can say is that 40 is 300% more than 10. And THAN. Or the new class is 300% more than the old class. Okay. If I want to know of, so of is like I'm taking this class and I'm comparing this size to the original. So it is a little bit simpler. I'm just doing 40 divided by 10 times 100 to get me of. So I'm comparing one to the other directly. I'm not comparing the difference. I'm just comparing one to the other. So in the more than, I have to take a difference. In the of, I do not. So 40 divided by this, the new class is the new class of 40 is 400%. And so in this one, we get 300, and this one, we get 400. And it's kind of hidden in here. So let me rewrite this, maybe a little more sense. This is like 40 minus 10 over 10. This is like the 40 minus 10. And we convert it to a percentage. I don't want to really bug you about that right now. This is what I want to focus on right here. So if we think about this, this 40 minus 10 over 10, if you think about subtracting common fractions, or fractions with a common denominator, this is exactly sort of reverse of that thing. And if you do that property, what you're essentially doing is taking one away from it. Taking one away as a decimal is like subtracting 100%. So you might notice there is 100% difference between these two things. This one is 100% less than this one, and this one will always be 100% more than this one. And so this one will always be a little bit more. This one will be 100% more than this one. Because this one we're taking a little bit away, right? We're taking 100% away to be exact. Hopefully that makes a little sense with our vocabulary as well. So if we say 40 is 300% more than 10, what that means is we take 300% of 10, which is 30, and we add it to 10 to get back to 40. If we say the new class is 400% of, what it means is we take 400% of 10, which means that 4 times 10 will get you to 40. And so we talked about more than. If it goes down, the new comparator value is p% of the reference value is 100 plus p of the reference value. If it goes down, so like in the previous problem, we had it going down with the Xbox. Let's bring that back up. We have a minus 40% on this thing. Okay, so we have this thing is going down 40%. So what we would say is that this is 40% less than. So going back to the Xbox, it was what the PS, I believe the PS was 40% less than the Xbox, is what we would say here. So if it's 40% less than, what we're comparing is the PS, which is 300, to the Xbox, which is 500. So if we compare this, this is going to give us, then I got to convert it to a percentage. I keep on forgetting to put this. And I think even in the book, at one point, they forget to put this. So, so you just have to remember to convert it to a percentage. So I believe it's in the later section. But this is giving me 0.6. And I got to multiply that by 100%. So this is giving me 60%. So what I would say is the PS is 60% of the Xbox. So we have to do 100 minus P if it's going down. So if it's going up, it's going to be 100 plus P. If it goes down, it's going to be 100 minus P. And the next example, we say that the area of Norway is 24% more than the area of Colorado. So the area of Norway would be 124% of Colorado. So it is going up, so we're going to add 100 to it. Javier's net worth is 6.4% less than Alicia's. Javier's net worth is blank of Alicia's. So if we want to do this, it is going to be 100 and we're going to take away 6.4%. So that's going to give us 93.6% of. So a store is having a 30% off sale. So now it's coming into applications with sales, and then we'll do probably some applications with taxes. Those are typically the easiest ways to add and subtract percentages from prices, right? Or from a number. So a store is having a 30% off sale. How does the sale price compare to the original price? So it's 30% off. And you can think of it, maybe we start with the price, and we're going to take 30% off of that price. So if you want to think about it, you could always put a 1 in front of your variable if it doesn't have it, a coefficient of 1. But what we're doing is we're taking one of them, or 100% of this thing. We're taking off 30%. And what this is going to give us is something like 70%. So this is the 100 minus 30 will give you 70% of the original price. So if it's a 30% sell, you're paying 70% of that object. Okay. So now we want to talk about percentages of percentages. So the first thing I want to say is straightforward is the percentage point. So that is kind of like your relative difference there. So when you see a change of difference expressed in percentage of points, you can assume that is an absolute change or difference. If it's expressed in, whoa, I missed off something there. Blank with the percent sign or words percents, it should be the relative change or difference. So I think it's just supposed to say percent change. Okay, I figured out what it was. So there's an extra word. If it is expressed, it shouldn't be there. If it is expressed with the percent sign or the words percent, it should be relative change or difference. So if we want the absolute change, we're talking about percentage points. So they will specify with this word points. If they don't specify with the word points, then we're talking about percent or with the percent sign. So here they want to know, assume that 65% of residents of Houston can play an instrument. The percentage of residents that can play an instrument in San Antonio is 25% higher than Houston. Okay, so if it's 25% higher, are we talking about a percentage or percentage points? This is talking about a percentage. So if it's 25%, it's 25% of something. It's 25% of 65. So you can think about what the 25% of 65 would be. 1625. And then you can add it back to 65 is one way to do it. We have 65 plus 1625. This should give me 8125. So this is one way to do it. And then we talked about the other way is if this is 25% higher, then this is 125% of 65. It's another way you can do it. And if you do it this way, it might be a little bit quicker. But either way, we should be getting something with a percent sign. That one should be the one with a percent sign. Sorry, this one should be the thing. This is the thing with percent sign. Now it doesn't have a percent sign. It has this thing called percentage points. So if Austin is 25 percentage points higher, this one should be the easier one. We're going to take 65 and we're going to add 25 to it. So I think this is giving me 90%. So 90% of the residents in Austin can play an instrument. Sounds about right. Too many people. Okay. We want to solve a few more percentage problems. I want to kind of get a hang of this. So to me, there's kind of two ways that this can go. And well, I guess it can either go up or down, or it can go new or old. So I guess there's a total of 4 different combinations there. But in this one, it is going, where are we going? Up. We have taxes in this one. We have taxes in this one. So our price is going up. From old to new, it is going to go up. So we are having an increase. This is going to be a more than problem. So the first one says you purchase a shirt that costs $20 before taxes and sales taxes are 8.25%. How much was the shirt? Okay. And this next one says the final price is $24.64 in a state that has 12% sales tax. What was the price before the sales tax? So this one is asking you for price after. This one is asking you for the price before. So these are asking 2 sort of different things. This is the first thing I hope you notice. So let's start with this. I think the first one is a little more straightforward. So if you purchase the shirt for $20 and it has a sales tax of 8.25. So one way you can think about it is I'm taking the $20 and I have to add 8.25% of 0.0825, sorry, percent of something. What am I adding 8.25% of? It's going to be of the $20. And so this is one way I can do it. I have this and this. And like I said, if I want to multiply by something that doesn't change anything, I can always put a 1 here. So if you wanted to do this, the 8.25% of 20 and add it back to 20, that is absolutely one way that you can do this. I want to show another way is that you can take 1.0825 of the $20. And that's coming from the fact that this has a common factor of 20. Then we're just doing the 1. Essentially what I'm doing is 1 plus the 0.0825. Factoring this thing out. And I'm left with 1 plus 0.0825 is going to give me 1.0825. So this is 108.25% of 20 is one way you can do this. And that should give me 2165, I believe. Okay, so this is one way, and to me, this is the more sort of straightforward way, hopefully. I'm taking this price 20, and I'm adding 8.25% of 20 to it. This says the final price is $24.64. My sales tax was 12%, so I'm just going to say 0.12 right away. What was the price before state sales tax was applied? So I don't know what my price is. And in algebra, if you don't know what your price is, you could let it be X. So I don't know what my price is, but I know I'm going to have to add some sales tax to that. The sales tax that I'm going to have to add is 12%. But this 12% is of something. It's not of the 24.64. So that is a really common mistake. People will try to take 12% of the 24.64. That's not the whole amount that we're talking about. The whole amount that we're talking about is this, the original price, which is my X. And when I add these together, I should be getting the price with tax on it. And I kind of said this, but if I want to put something here that doesn't change it, I can put a 1. I can put a decimal, some zeros in there. But I have 1x plus 0.12x. So another way to think about this is 112% of some price is going to be 24.64. So if you want to do a little bit of algebra to solve this thing, what we're doing is we're dividing both sides do it in red so it's not cramming it together too much. We're dividing both sides by 1.12 to get x. So if we want to get x, we have to divide both sides by 1.12, and I set it up nicely, so I believe it should be an even $22. So let me double check, make sure I'm doing my math right. 24.64. Yeah, should be an even 22. So the shirt is that what we're doing? It doesn't say, but the object was $22 before tax. So this one is again like the more than, sorry, I'm mixing things. If I could do 12% more than, I'm doing 112% of, or sorry, yeah, 112%. But this is a bit backwards, so I actually have to divide by the 112% in order to get my original price. So it's not multiplying by 112%, it's dividing by 112% to work backwards. And I think that's what the book gives you, something like this. They give you final value equals 100 plus p times the initial value, and then they give you another one that's solved for initial value. So they also give by that percentage. It is the same formula, just solved for different things. So those are the two sort of formulas the book gives you. Okay, so now we got, that's really no, I don't know who writes these problems. So ahoy matey, you better fly and squawk and tell all your friends because there is a 28% off sale at the International House of Parrots, which is the lesser known IHOP, by the way. A new Amazon parrot usually costs $850. What is the sale price? Okay, so if it usually costs $850, and it's a sale, that means we're taking off money. We're taking off 28%, but we're going to take off 28% of what? We're going to take off 28% of the original price, which is the $850. So you can do it like this, is okay. But I have one $850 and I'm taking out 0.28 of the $850s. You might figure out that's the same thing as taking 72% of the price. And I'm taking out 28% off of something. I'm only paying 72% of it. So this one is straightforward. We know that we have a original, we have the original cost and we know the sell amount. And so we're paying 72% of the original cost is one way to think about this. You purchase a new macaw and the sell price is $7.92. So what we don't know is the original price. So that's what they're asking. How much would this have been originally? So this is the one that's maybe a little more difficult. But we're taking one of the original price and we're going to subtract 0.28 of the original price. And it's going to end up giving us this thing that they give us here is $7.92 is the sell price. And so another way, like I was saying, is I'm taking 72% of the original to get to that $7.92. And in order to get to X, what I have to do is I have to take that $7.92 and divide it by that 72%. So if I take $7.92, divide it by 72%, I should be getting $1,100. So $1,100 was the original price of the macaw. And the sell price is $7.92. So this is the formula they give you in the book. If I take off 28%, this is like 100 minus 28 is giving me 72% of the original price. And then they also give you the other sort of form of the same formula. So I'll go ahead and write it. So the initial value is equal to the final. over that same percentage. So if you're going one way, you're going to have to multiply by that percentage. If you're going the other way, you're going to have to divide. Okay, and just to be clear, that concludes the first section about how to use percentages correctly. So now we're going to talk about ways in which we do not use percentages correctly. Common mistakes that people use or people make when they are working with percentages. And so this section is titled Abuses of Percentages. And so the first thing that they want to talk about is this thing called shifting reference value. So if you invest in stocks during the first year, the value fell by 500, I can't even read, fell by 50%. The following year, it rose by 60. Your stockbroker is quick to point out that you're 10% ahead. Evaluate your broker's comments. So you could do this with variables if you really wanted to do it with variables. Or you could just assume you have some amount, right? If it's not true of a certain amount, it's not going to be true of all amounts. So what he's saying is not true in general, right? And so you can verify that he's lying just by creating one counterexample. So if we assume we have like a certain amount of money, I don't know, let's assume we start with $1,000 during the first year. And if you really want to be really simple, you can just start with 100. I want to be really lazy. So if we start with 100 and it fell by 50, now we're at $50. And part of this is because we're doing 50% of 100. If it falls by 50%, it's falling by 50% of 100. Okay, so now we're at 50. And then the next year, it's going to rise by 60%. But now we have 50, and now it's rising by 60%. But it's not rising by 60% of that original 100. It's only rising by 60% of 50. So 60% of 50 is going to give me, I believe, what, 3.6. Going to give me 30. So now I am at 50 plus 30 is going to give me 80. Okay. So you started out with 100, and now you're at $80, and your stockbroker is trying to tell you that you are ahead. So you are probably not going to be too happy at your stockbroker because you are $20 down. And he's trying to tell you you are 10% ahead. So that is not an accurate thing. Why is that not an accurate thing? And it has to do with the shifting reference value. When we took off 50% here, what we were taking 50% off of was 100. But when we took 60% up, what we were taking 60% up from was only 50. So even though these percentages were only 10 points apart, they weren't referring to the same whole part. The reference value was different. Okay, and so now we want to look at 13, which I bring it down a little bit, huh? Politician claims that they will cut taxes by 10% each year for the next 4 years for a total 40% tax cut. Evaluate the politician's comments. Okay. So again, I don't know, tax cuts by 10%. So assume you are paying some amount. Let's do 1,000 this time. And if we do 1,000, and we're going to reduce it by 10%. 10% of what? We're going to reduce it by 10% of 1,000. So 10% of 1,000 is going to be 100. So the first year, my taxes are going down to 900. The second year, I have 900, and I'm reducing it by 10%. I'm reducing it by 10% of 900. So 10% of 900 is giving me 90. So 900 minus 90 is going to give me 810. Yeah, that's it. Okay, now I'm at 810. And I'm reducing it by 10%. 10% of what? Now I'm at 810. So 810 minus 10% of 810 is minus 81, is 729. You might notice this is not going down by 10% each year. If we went by a total of 40%, that would be 600. Right, down 40%. Would give me 600. So I think you might want to do it one more time for the last year, just to maybe prove it to yourself. 729. I can't write the number correctly. 729 minus 10% of 729. 656.1 is the number I'm getting. So that is definitely not cutting it down by 40%. And why is it not doing it? Because we are reducing it by 10%, but that 10% each time refers to a different amount. We're shifting the amount that we are referencing. And so you have to be careful about what the whole is that you are referencing. Whew. Dropping calculators again. Crazy Kathy's Cornerware Emporium Extravaganza. Everything is 150% off the market price. Evaluate how crazy Kathy is. So this is the less than nothing thing. You cannot take 150% off a market price. You are going to be giving money out. Nope. She's not going to make any money. She's going to be giving money away. So let's not do that. Tell her to stop. You can't have a sale that's more than 100%. There are realistic bounds that we have to take into account sometimes. And so you can't have sales of over 100%. 100% off is already, you're giving it away for free, right? Okay, so anything over 100 is a no-go, is what they're trying to say. You can't have less than nothing. Next one is about averaging percentages. So if you take a quiz and you get a 70% of the problems correct, and you take a test and you get 80% of the problems correct, is it say that on both combined, you answered 75% of the questions correctly? Okay, so again, let's take two different numbers. So there's a 100-question quiz. Let's just say we have 100 questions on the quiz. We have 10 questions on the test. So there are 110 questions total. If we want to think about the ones we got correct. So if it's a 100-question test and we made 70, that means we got 70 correct. If it's a 10-question test and I got 80%, that means I got 8 correct. And if I add them two down, I'm getting 78. And you could probably already tell. Well, maybe not. This is a little confusing. But I got 178 correct total out of 110. So 78 out of what, 110 is going to give me 0.709. So that is almost a 71%, right? That is nowhere near the 75 that they took by averaging these two things together. And so in general, we don't average percentages. So I picked 100 questions here and 10 questions here. Coincidentally, it will come up the same if you have the same amount of questions. So if you're taking from the same base, then it does come up correctly. But most of the time, you're not going to have the same amount of questions. And most of the time, we're not going to reference the same reference value. These are different reference values that we're referencing percentages of. So I said 70% here. 80%. So I'm doing 70% of the 100. I'm doing 80% of the 10. So I am having different reference values, and anytime you have different reference values, you don't want to be just averaging these percentages. All right, so that is the last abuse of percentages that we're going over. That is the last section in this, that is the last topic in this section, and I will see y'all pretty soon. Be sure to look at the next section. What 3B is coming up next. And so that is all about putting numbers into perspective. So I will see y'all soon.